Hello, I'm Nanix, and this is part 4 of the Let's Make a Survivor tutorial series. In this part, we will be implementing damage to complete the previous episode's state machine, all using interfaces. To begin, we'll create a folder for the interfaces, within which we will create a new script called IDamageable. Open that up. So, an interface is simply a contract that tells the compiler what to expect when it is implemented. In this case, what we'll want for the player and the enemies is a float called health, which we can get and we can set. We'll want a method called damage, which takes in an amount, and we'll want a method called heal that also takes in an amount, if I could type correctly. We also need to change this to interface because it's not a class. So anything that implements this interface, the compiler expects to have these two methods and this one property. Now we'll jump over to our enemy, scroll all the way up, and just here, comma, IDamageable. Now it's going to yell at us, very similar to how the control setup worked with the input handler. We'll just implement this interface, which is going to give us this here, the get and a set. And it should also give us the two methods at the bottom, for heal and damage. Okay, let's now put this into semblance. So we'll change this to locomotion, and then we'll use header settings here. We'll add a serialized field, private float health max. Leave that like that, and going to do a little bit of shuffling around here. I'm going to make a function called, or rather a method called initialize, autocomplete, in which we set that, and we also want to set our health to equal health max. For now, we'll just have start handle that, but this will come in handy later when we do the object pooling. So now, down at damage, we can go health minus equals amount. If health is less than or equal to 0, don't want to return. We then want to ensure health stays at 0, and we want to call death, which we'll call here. And very much similar here. We want our health to increase by the amount that's provided, and if the health is greater than or equal to health max, then we set health to health max, and remove. You don't die when you have full health, so we remove that there. For now, we'll just have this destroy the game object, as we still haven't got pooling set up yet. And that is now the interface set up on this enemy. However, we have nothing that currently interacts with it. So let's go to our player, and we'll do exactly the same thing. However, there will be a little bit of a difference here. So let's implement these. And now what we want to do here is this float should return the shared health variable we set up last time. Right here, dot shared. And when it is set, we want dot shared to equal value. So now we're still using this shared float for the player's health. Much like we've done with the enemy, we'll change this to locomotion. Whoa. Header, settings, and we'll add the serialized field, private float health max. Start that at 5 by default. Did we put a default on the enemy? I don't recall if we did. Ah, we did not. We'll set this to 1 by default. Just for now. Okay, and exactly as we've done with the enemy, we can quickly grab these, overwrite these ones that have been implemented here, and we don't have a game over setup or anything like that at the moment, but we'll just prepare it. Player has died. So at the moment the game won't end or anything, it'll just leave the player's health at 0. And now we'll hop over to the enemy and implement their attack cycle. So, first of all, we'll use code to actually implement a small little telegraphing effect. Under the enemy empty, we'll right-click, we'll create a new empty, and we'll call it telegraph. Within this, we will add a cube called effect, and we'll move this up 0.5 on the Y and 0.5 on the Z. And remove the box collider because we don't want this colliding with anything. It's just a visual effect. To that end, we'll create a new material. We'll call it transparent, why not? We'll make it transparent. We'll make it red. And we'll reduce the smoothness, ensuring that we set the alpha on this HSVA, or if you're using RGBA, then it'll be one of the other ones, to at least 50%. Drag that on there, and now we've got a little transparent box. Going to disable that for the moment, and then in the enemy, we'll jump back into this script here, and we're going to create a new variable under, where? Under the telegraph. Serialized field, private, transform, telegraph, visual. We'll have to ensure that we set that. Then when we start our telegraph, which is here on enter telegraph, if telegraph visual exists, just above here, so we keep it all in the same area, we'll create an I enumerator, because this is going to be a coroutine. We'll just call it animate telegraph. I suppose we'll add a float for the duration in there. So in the outset, we need to grab the telegraph visual, .gameObject.setActive, and make it true. And before we do anything else, we need to set up a few more variables. In this case, we'll do it under the attack heading. And these will be a private vector2 called attack size. We'll make it vector2.1 by default. We also want a private float attack range, and we'll make that equal to 3. In fact, we'll multiply this by 1.5f, so that'll make it nice and chunky. Next, we're going to need to set up the layers, so we'll use a layer mask, and we'll call this one target layer, specifically so the attack doesn't hit the enemy themselves. We'll change this over to attack damage, just so that we keep consistent. And finally, we don't need to serialize this one, but since we'll be using the non-allocated version of the overlap box in the future, we want to set up a container for that information. So we'll make a collider array that has a size of 8. Even though technically it should just be 1, we'll make it 8 for now. Excellent. Now, down here, where we're setting this telegraph up, we need to set the scale, initially, to a new vector3, and take into account the attack size x, dot x, the attack size dot y, and to ensure that we don't blow our eyeballs out in case we're using bloom, we'll have to set the z-axis to 0.01 at minimum, and this will be applied to the local scale of that transform. Next, we need to make a timer, so we'll set time equal to 0f, and then a while loop. While time is less than duration. While loops are quite dangerous. Make sure you're paying attention when working with them. We need to increase the time by time.delta time each loop. Grab a percentage of that time. So time divided by duration. And then we'll set the telegraph visual.local scale to equal a new vector3 attack size x, attack size y, and then we want the attack range multiplied by the percentage of this process. Did I misspell percentage? I did. Percentage, not percentage. Then we need to yield return null. That will create a loop, and eventually, once the loop is finished, we want to set the telegraph visual.gameObject.setActive to false. So we're hiding the object. When this triggers, it will activate the object, set its default scale to a tiny sliver, and then over the next duration time, it will increase to its full attack range, and then it will hide itself. So when we enter the telegraph, all we now need to do is start coroutine, animate telegraph, telegraph time. Excellent. And now if we jump back over to here, we can grab that telegraph that we created before and drag it into the inspector on the side here where we have the visual set, hit play, and we should be able to see it in action. The enemy runs up. Yay, he's trying to attack. Aha, so I'll need to change the range a little bit. Let's make him go to about 10 units. Excellent, that's within range. Now to implement the next part, the attacking. So, when we attack, we want to immediately array.clear the attack hits array that we set up earlier from the 0th index to the maximum of the indexes. Why are you screaming at me there? Ah, I see. So it's system.array.clear. Okay. Then we need to set a local variable called hits, and we're going to make this work with physics.overlapBox non-allocated. Within this, we're going to set transform.position as the origin. We want to push it forward by half of the attack range and lift it up by half of the attack range, because this origin point is the center of the cube that is created, or the center of the box that's overlapping. So we'll go transform.forward, as that's the direction the enemy is looking at, multiplied by attack range divided by 2. Technically we should be doing multiplication because it's easier, though at this point there's not that much variance in optimization. Still, I'll do it this way. Then we need to add vector3.up multiplied by attack size.x divided by, oh no, it'd be y, sorry, y, divided by 2, so multiplied by 0.5f again. The next entry will be the half extents. So we need to give it half of the size of the box, as it's going to grow from the center out to that limit, which means we need to enter a new vector3, starting with attack size.x multiplied by 0.5f, attack size.y multiplied by 0.5f, and attack range multiplied by 0.5f. Oh, be careful there. Okay, and the next step is the variable called attack hits that we set up earlier, where the results will be saved to. Then we also need to continue by adding an orientation. In this case it will be transform.rotation, because that's the way the enemy is looking. And one more, which we set up earlier, is the target layer, the layer mask that we want to actually target. After we've done this, we need to see if the hits are greater than 0, If they are, something has been hit by the overlap box, so we need to loop through. I equaling 0, limited by the amount of hits that have happened, and then grab the collider, current equals attack hits, and the current index. And from there, we then go if current.transform, so we're getting the transform, dot try get component out the interface we provided, IDamageable, damageable. And if this is true, then we want to use damageable.damage with attack damage as the parameter. Oh, not attack range, attack damage. Okay, so what's happening here? We've hit something with the overlap box, because this is greater than 0, and this reports how many hits this overlap box has done. Next, we loop through the amount of hits that we have. We grab the attack hits from that array that we cleared up here, and we have set up here as the result. We then grab the transform of that collider that we've hit, and we try and get the component IDamageable from it. IDamageable is the interface we set up. It's a contract, so the compiler knows if something has this IDamageable, it's going to implement these functions and this variable. So I can then immediately say, if you have successfully got this component by trying, then run damage and apply attack damage. And voila, we are ready. Although there is one more thing we need to do, and that's set up these target layers. Jumping back into the editor, we will open up the layer menu, which is up here at the top right. Click Add Layer. We're going to make layer 6 called Player and layer 7 called Enemy. Click back on the enemy and select it from the drop-down now. We'll only change this upper object. So no, this object only. That's just in case anything you've added here you haven't removed your box colliders from. We only want it to collide with this collider here on the root. And we'll do the same thing with the player. No, this object only. And as a final step, we now need to just apply that to this target layer setting here. We want the enemy to target the layer player. Now if we hit play, the enemy runs up, telegraphs his attack, and hits you for 1 damage. Constantly. Perfect. We now have the enemy dealing damage to the player. Let's now set up a very simple way for us to do the reverse. And while we're at it, let's just jump back into the state machine here and remove this line. Just so that we don't fill our console log with nonsense. Okay, so we'll jump over to the player. And we'll set it up in the on jump, so when you press spacebar, it'll do an attack. I'm just going to quickly grab this over here from the enemy. This whole block, actually. And we'll paste that over here, and we just need to do a few alterations now. So since this is only temporary, I'll just set up a quick results equals new collider, and we'll make it limited to 16. So set up a new temporary array that we replace there, and we'll just magic code this in for the moment. This is only temporary. So we want this overlap box to start from the player's position, and we want to move it up on the y-axis by, let's say 1.5. We'll make the box itself a vector 3.1 multiplied by 3. Ah, right, it's half extents. So this should actually just be 1.5 as well. And we need to set up a target layer, so we'll just do that up here under settings for the moment. Target layer. Okay, and then we need to change this over here to... We'll just make it do 1 damage. I believe we set the enemy health at 1, so that should instantly kill them whenever you press the spacebar. Now if we jump back over into the editor, jump onto the player, make sure we set that target layer to enemy, and then we can hit play. And the enemy dies. Excellent. To make things easier, specifically when working with these physics casts from code, there is a plugin I generally like to use, and it's this one here, from Rotary Heart, the Physics Debug extension. It's completely free. Let's just add it and I'll show you how it works. So that should add it to this Unity, opens up my assets, auto goes to it, and then I can import it into this project. Okay, one thing we do need to do, because it hasn't been fully updated, is jump into here. You can just reload that. And in this script in particular, we just need to add pragma, warning, disable, and the code was CS0618. So 0618. That's just a depreciation warning, because we're no longer using certain 2D raycasts anymore. Okay, that cleans up our console log. Now to actually implement that plugin we just added. It's quite simple, really. We'll just jump over to our script here, and then it's as simple as going using physics equals rotaryheart.lib.physicsextension.physics. Okay. And with that, we've now overwritten Unity Engine's physics, but this one just implements that with a few extra settings. We can now go Rotary Heart Physics Extension Preview Condition both as this one, and we want it to last for 0.1f. That's the duration. It's a bit hard to see with your overrides popping up here, but if we just hover over here, it tells us. So you've got the standard setting, which is center, half extents, collider results, the orientation, the layer mask, and then you've got a preview type, which is optional, and a draw duration, which is optional. You can even change the color after that too. However, we'll just leave this as default for now. And let's do the same thing in the player script. Adjusting that, grabbing this using statement from the top here, and pasting it there. Now when we run the game, we can debug those boxes and see what's happening. You can see the overlap box is spawning. It's flashing for 0.1 of a second when it's generated. It flashes green when there's a valid hit, or red when there's no hits. So, goodbye, Mr. Enemy. Excellent. If you find this interesting and want to follow along, please subscribe to my channel. If you have any questions, queries, or feedback, please head to the comments section and reach out. Thank you for your patience with this series. I'm currently in the middle of heavy assessment work in my course, so delays may continue in the short term. Thank you for watching.